Hi, in this little video we're going to take a look at the idea of what's called a discrete random variable in the study of probability. Like many things, it's an expression which means something quite simple really. Discrete means it's a counting number, 1, 2, 3, 4. Random means it can take any particular value, and the variable is just like a variable that we get in any other branch of mathematics. So there are also probability distribution functions here. So these things that we're going to take a look at are probability distribution functions. I'll write that out for you, probability distribution functions. And there are many of them. We're going to see a few as we go down the page. So their probability of these things always adds up to 1. And they usually use just counting numbers as their random input. So for example, I could take any one of these functions and say, what is the probability that it will take the value 0 under given circumstances? Or what is the probability it will take the value 1 under given circumstances? Okay, so it's counting numbers, but that includes 0. Okay, so they come on all shapes and sizes. The one we're going to take a look at, because it's quite simple to understand, is the binomial distribution. Okay, and in the binomial distribution, we're looking at what are called Bernoulli experiments, which allow for only 2 possible outcomes. And the common one, we've already seen it a little bit, we're just going to take the maths a bit further this time, is to flip a coin, heads or tails, and we assume that either of those outcomes, head or tails, are equally likely. The probability of each one is exactly the same. And we can actually introduce some language such that we can say that the heads is called a success and the tails is called a failure in the experiment. But that's just semantics. You can assign any names you like to that really to understand what's happening. So if we take a look here, this is a diagram we've seen before. It's a tree diagram of what happens when you flip a coin. And you go one way, you've got a head, the other way you've got a tail, and then you flip a coin again at this next point here. You've got a head, and you've got a tail, and you've got a head, and you've got a tail. And we like to ask ourselves, what is the probability that we'll get a particular kind of distribution at each particular level? Here there are 8 possible outcomes, head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, which is the same as 2 to the power 3. It's a binomial distribution. That's why there's a 2 appearing there, because there are 2 possibilities. And we've flipped the coin 3 times in this case. So there are 8 possible ways of getting different results. So we analysed that in the past here. What's the likelihood that we get 3 heads if we flip a coin 3 times? There's only one way to do that at 50% each time. There, there, and there. Only one way to do that. 3 flips, 3 heads. We're going to now introduce the language. You may have seen it before, but this is the language of what we call combinations. If I take 3 flips and I choose to have 3 of the same thing, that's called 3 choose 3. And that gives you actually just one possibility. We're going to see this build up later on. If I say I'm going to flip a coin 3 times and I only want to choose 2 heads, we can very quickly see that there are a total of 3 ways of doing that, getting 2 heads in the mix. That's 3 flips, 2 heads, 3 choose 2. And there are 3 possibilities. The other one, instead of having 2 heads, we can have just 1 head, or in fact 2 tails, which is just the flip side of that. So there are 3 ways of doing that also. 3 flips, 1 head, 3 choose 1, and you'll find that also gives you a 3. And the final one, no heads, which is as much to say 3 tails, 1 way, 3 flips, 0 heads, 3 choose 0 gives us 1. Now, that whole process of finding out how many combinations we've got is long and can be a bit tedious. It's not difficult, it's just long and as I said, can be quite tedious. There are many ways to work out that pattern, but the one that we're going to look at is the combinations formula. Okay, so the combination formula, and you can find that in any decent maths textbook, looks like this. It's this one here, where n represents the number of flips and x represents the number of choices from that number of flips. So there's an n factorial. N factorial means n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. Underneath in the denominator you've got n minus x factorial, and then you've got x factorial. That formula comes from a place where we're not going to look for now, but you can find it in the textbook. So, for example, if you chose 4, choose 3, n is equal to 4 in this case, and x is equal to 3. So we can say n choose x if you like. Using our combination formula, we can write 4 factorial divided by 4 minus 3 factorial times 3 factorial. And that particular number will give you 4 if you work that out. 4 times 3 times 2 times 1 divided by 4 minus 3 is 1, so that's 1, and 3 factorial is 3 times 2. And when you do your calculations there, you should be able to see that that returns us a value of 4. So you can see it's 4 by doing it longhand, okay, getting 3 from 4. There are 4 ways of doing it, and that's exactly what our formula generates for us. So from now on, we're just going to assume that this bit will tell us how many different combinations we're going to get. And with the binomial formula, the added thing you get is not only do you get to find out how many combinations there are and what those combinations might be made up of, you also get to work out the probability of any particular combination. Now, with flipping a coin, it's fairly straightforward. We're assuming that the coin itself is fair. The probability of a head is 50. The probability of a tail is 50. So when we actually work out the total probability for a particular thing, if you imagine going back to the top here, a success in this case is 50%, another success is 50%, and another success is 50%. If we had a different set of numbers, we might go that way once, this way once, and that way once. And each of those different paths will have a different probability attached. In the case of the coin, the probability is the same, but as we're going to see later on, that probability in each direction does not have to be the same. And this is a very powerful piece of mathematics which goes in all sorts of clever directions. So let's just move the screen up a bit and see where we are. So we can now add information about each possible combination using the binomial formula, which includes the probability element of success and failure. So in this little image here, the n over the x is n choose x. That's the combinations part. And this bit is the probabilities part. There's going to go the successful route x times, which means, by definition, it's going to go the unsuccessful route n minus x times. So that's all it is. This works out the total number of possible combinations for a particular thing you're asking, and then it calculates the probability associated with that particular combination. I've written that out here. Once again, the file will be available for you to see in Moodle at the end of this particular session. So now to bring in the element that I mentioned there, that going down one route or the other doesn't have to be the same on both sides. If we imagine that we had a biased coin, say the probability of getting heads is 0.6, then the probability of 3 tails from 4 is like this. 4 choose 3, that's the number of combinations. Then 0.6 to the power of 3 means it's gone down the 0.6 route 3 times. The other part is the 0.4, which is 1 minus 0.6, and it only gets one chance to go down that route there. When you calculate that out, you get this number here. get your calculator out, you can check that that number is correct. We're going to see a quicker way to do it for the actual course, because getting you to work those out that way all the time is just going to block you up with calculations rather than your understanding of the binomial theorem. So I'm going to show you an Excel spreadsheet in a moment. So we can apply this to any two outcome situation with known probabilities for each outcome. So here we go. If we now flip a slightly biased coin 8 times, what is the probability of getting 3 heads if the probability of 1 head is going to be 0.55? So the first part is to find out how many combinations of 3 we can make out of 8 flips. You're going to find later on that that number is going to come to 56. If you actually put that into the formula that I gave you further up, that comes to 56. We then have the likelihood, let's move that out of the way, the likelihood here of 0.55 to the power 3, which is this number here, and then the 0.45 to the power 5, the remaining 5 flips. Notice that that number plus that number equals this number here. Okay. This bit here gives you 0.0185, and when you add those two numbers up, you get 0.179. So the probability that you're going to get 3 of those heads from, sorry, did I say heads or tails? Getting 3 heads, yes, is 0.179. So those calculations are tedious, but they're straightforward in a number crunching device like an Excel spreadsheet. So that's all for this video. In the next one, I'm going to take you to the Excel spreadsheet that I've created, which is going to help you solve some of the problems in the class and will help you when you come to do your statistics project. That's all I've got to say. Take care, and I'll see you in the next video.